Hey guys, so today we're going to start by looking at the greatest integer function. Now the way we're going to write this in this class is f of x equals, and we're going to use brackets, x. So there's actually many different ways that people notate this. This is what we're going to do because, in my opinion, it's the easiest way to write it. So for this function, what do these symbols here mean? What does this mean? What it means is the greatest integer that is less than or equal to x. So whatever's inside of here, we have to get the greatest integer that is less than or equal to it. In other words, we're just going to round down. That's pretty much what this function does, is it rounds down. Okay. Some people call it the floor function. Some people call it the step function. And a lot of people write it a lot of different ways. So this function is used a lot in programming. It's used in different fields of mathematics, and they all just have their own different ways of writing things, even in the same field. So here are some different ways you might see this symbol. Your packet thing, whatever you want to call it, uses this notation. I don't see the point in writing some extra little lines in my brackets. Waste time. I actually prefer this symbol right here. I used it a lot when I was programming stuff, but it's not on the keyboard. Yeah, nope. So we're just going to go with that. That's on the keyboard, nice and easy to type. We're going to do that. But these are all different ways that you might see the greatest integer symbol. They all mean the same thing. They all mean this. Now let's look at some examples and pay close attention to detail. Okay. See, here's how they have it written. Again, I'm not going to the book, but I'm going to use the just straight brackets. So for me, it's easier to just do that. Anyway, let's do it. F of 7. Well, that's the greatest integer of 7. Well, what's the greatest integer that is less than or equal to 7? 7. Okay, nothing really interesting there. It is what it is, right? 7's an integer. So the greatest integer function is just going to give itself back. 2.3. All right, now this one's a little more interesting. Got to remember, what are our integers? Well, we got our natural numbers, those are the guys on our fingers, and 0, and the natural numbers are, some people call them whole numbers. We just call them natural numbers here. So the fingers, the numbers on your fingers, that's your naturals. Next, we have the integers, which is your numbers on your fingers and the negatives of them. So 1, 2, 3, 4, 5, and negative 1, 2, 3, 4, 5 for both ways. Decimals aren't in there. Can you have a decimal for an integer? So what is the biggest integer that is less than or equal to 2.3? Well, let's see 2.3 on a number line real quick. I'm pretty sure half of you at least are like, what the heck are you doing? It's obvious and easy. It's good. But let's just look at it. Here's 0. Why is this? Okay. 0, 1, 2, 3. And right here we got 2.3. Obviously, that should be more to the left than the middle, but whatever. Who cares? So what is the greatest integer that is less than or equal to 2.3? Oh, hey, look, it's 2. Again, what does that mean? It means round down. And so if we round 2.3 down, that's just going to be 2. So the answer here is 2. Okay, not too terrible, right? F of negative 4.8. Let's see. 4.8. So this means the greatest integer that is less than or equal to negative 4.8. Well, that's obvious, right? That's negative 4, isn't it? No, it is not. -4 and -4.8. Let's compare those numbers. We got -4.8 and we got -4. Which one's bigger? Let me use a different color. The -4 is bigger, right? Would you rather owe somebody $4.80 or just owe them $4? Well, I like to owe less money, so yeah, there it is. Okay, you're more in debt if you're at -4.8. So what would the answer be? We'll round it down. Draw a number line. Let's look at this thing again on a number line. Give me my negatives. How about I go over here? I'm gonna start at -6, -5, -4, and who cares? Whatever. If I plot -4.8, that's going to be like right here, isn't it? So what's the greatest integer that is less than or equal to? Less than or equal to -4.8? We got to go to the left. That's where the small numbers are, aren't they? We have to go to the left. We can't go to the right. That's bigger. We got to go to the left. So that's -5. Okay. Okay. Calm down. It's okay. Don't panic. Go get it. Let's try another example. Actually, let's just do one more like this. The greatest integer of -10 point. How about 99999? I forget how many nines I said. Let's go with that many nines. What is the biggest integer that is less than or equal to -10.9999999? Number line. Here's let's see, -10, -9, -11. This is right here, isn't it? Yeah. So -11. That's what the greatest integer of this thing is. So if it's negative, you kind of got to think about it backwards, because the negatives, the bigger the value of the negative number, the smaller the actual number is, the absolute value is. Okay. So now we have the greatest integer, plug in 9. That means you replace x with 9. If you're comfortable with it, you can put parentheses in there, like we usually do. I'm okay with not putting the parentheses because all we have right here is an x. If we had a 2x or something, you might really want to put some parentheses. For this, it's okay. I'll let it slide. Simplify. Pretend it's just a regular parentheses, which is why a lot of people use different symbols, because this could be a regular set of parentheses if we're doing just some order of operations. Anyway, what's the greatest integer of 4? 4. It's less than or equal to itself. And 4 is definitely less than or equal to itself. Okay, here we go. Next problem. 0.5 minus 5. Use a calculator if you must. Oh, hey, I don't even know if this is on the calculator. It might be. I'll pause the video and look for it. Be right back. And I found it. Yep. Casio FX105 Plus does indeed have it. It's got another win. That's the int G button, not the int button. So if you do alpha, the minus sign, you get int G. And if you type that in, let's go back to what we already did. Hey, let's do this one. -10 point. Much nice. You get -11. There you go. So greatest integer function, I guess that's what the G is for, greatest integer. does indeed give you, well, I forgot what I was going to say. Anyway, the Casio FX115ES Plus does indeed have a greatest integer function on it, so you can just type it in here. So I could just type in alpha minus 0.5 minus 5, and that's -5. Or, not have this calculated, even though I've told you 100 times get it. You'll get a fraction, make that a decimal, that's -4.5. And again, it's the greatest integer that's less than -4.5, so we've got to go to the left. That's going to be -5. And if we look at this one, -8.1, we're plugging that in here. Got this calculator, just pop it in there. Alpha minus -8.1 minus 5 is -14. Okay. Let's see why that is. Get that, which is -13.1. Stand drawing those double brackets every time. So it's got to go to the left. It's negative. So the next number to the left is -14. There it is. Done. And for now, I think that's going to be it. Well, let's graph. Oh, the graph. The graph is extremely important. Yeah, we're just going to graph the basic mother function. We're starting those for the greatest integer function. Yeah, that's all we're going to do. So let's get some values. We got 1, 2, 3. We got 5 to 5. We got how many squares here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, I guess we'll put 0 here in the middle and go either way on it. Hey, I want to get myself out of the way, not bigger. There. So, I mean, whenever we're making a table of values, right? Numbers. Let's see what happens here. I mean, it's just going to be what it is, right? The greatest integer of -4 is -4. I don't know. Let's see. 0, it's the same thing. I don't know. We might need to do some different values. Let's plot these first. But if it is -4, it is -4, right? So I got a solid dot there. -4, -4. Okay, I got a solid dot here. -3, -3, -2, -2. It's looking like the y equals x function. I don't know. That's not interesting. Talking about an interesting function. That ain't interesting. It's just gonna be a straight freaking line, huh? Not if you choose some different numbers to test. Okay, instead of -1, what if we do -0.5? And -0.9. Ooh, what if we do 2.3 and 2.7 and 3.99999, whoever who cares how many nines. And go to 5, right? So how about we're gonna go to 5, okay. 4.7. And then -2.22, -3.314, random crap there, just putting it there out there. No. Have you gotten the pattern yet? Hopefully you have, so we can do this real fast. Plugging in the greatest integer function, we gotta go to the left. Just what's the left of -3? -4. All right, we're at -3.3, -2.2. That's gonna be -3, right? That's gonna be -1. That's gonna be -1. 0, 0. If we have an integer, it is that number. So at the integers, they are not changing. The integer is the same. Actually, these dots are. So at each integer, that is gonna be the same. So 2.3, but we got to go to the integer to the left. That's 2. Well, I'm saying to the left, I'm talking about on the number line. That's also 2. 3.999999999. That's still gonna gotta go to 3. Gotta go. Yeah, exactly. So, well, let's just do it. I mean, negative 3 point. So negative 3 and thirdish. Negative 3 and a bit. So we got something over here. Oh wait, no, we don't. Do it's negative 4. It's got to go up there. And oh, I guess I could put this that too. Can I forgot that dot earlier. Sorry. Negative 2.22222 would be down here. And I mean, we could pretty much do this, huh? Yeah. Negative 0.9. That's good. Negative 1. That's like right here. 0.5 is right there. So you see it? Do you see what's going on? Do you see what's going to happen? 1, 2, 3. So all of these are looking something like this. The only thing is, where does it stop? Well, if I had 3.1,000,000 the greatest integer of that is still 3. So what we do, we go all the way up to the next number. So if we had 0.9999, we go all the way up just until 1. Anything up until 1 would be 0. So 0.99999 would go to 0 for the greatest integer. So I'll put an open circle right there. These guys are just going to be a bunch of open circles under here. That's not open enough for me. Let me make that open. That's better. Yeah, I said it wrong. Sorry. Same thing over here. If I have negative 0.00000000 zeros in a 1, that thing's got to go down. It's got to go to the negative 1. If I have negative 1.52 zeros in a 1, it's got to go down. So this is made out of a bunch of little horizontal lines. Right there. Forgive me for sucking at drawing, but you see it. You see it. You can see it. Might not be able to see that. And pretend I'm actually on a line. And there we are. That is the greatest integer function's basic graph. That's why they call it the step function. It looks like some steps. You know, you're jumping up and down some steps, climbing the steps. That's what it looks like. Now, we could do some stuff like if we added 1 out here. Oops, that's not what I wanted to click. Now we could do the greatest integer function plus 1. And that's, well, we're going to figure out what that does, but I'll tell you, it's going to look like that. But you haven't learned that yet. We're going to. That's what we're actually about to do. That's why I'm wearing the shirt I'm wearing. What is the domain of this thing? Well, look at it. I mean, is there any x value we cannot plug in here? Ooh. What about square roots? What about square roots? So let's try. Can we do square roots? What's the square root of 2's greatest integer? I don't know. Hey, Cassie, what you got? Greatest integer of the square root of 2. Oh, hey, look, it's 1. We know that because square root of 2 is rounded to 1.4, blah, 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 blah. It doesn't really matter what it is. 1.4 something, something, something. That's to the left of 2. So We can't go to 2. It's between 1 and 2. So the greatest integer of that is 1. So yeah, we can include radicals and any other irrational numbers. There's nothing we can't include, right? We can include all real numbers. We can take the greatest integer of any of those things. This video is way longer than it should have been. Sorry. Range. What's my range here? I can't say it's -1 to I can't say -10 to infinity because it doesn't include all these things. It's just the integers. I guess one way you could write that is like this. The integers. Yeah, we're going to use set notation, guys. Set notation. -5. Well, actually, let me start with some ellipses. That's this 3 double dot thing, make it bigger. Dot, dot, dot. You know, to continue on going forever. -5, -4, -3. We got everything, and I should have started something. And then we got la 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 la. Why am I drawing this? Let me type it. Something, -5, -4. It's all of our integers. All of them. So that's how we write it out in set notation. You don't have to go to the 5s. You can do just do negative dot dot dot. That's important. -2, -1, 0, 1, 2, dot dot dot. Dot 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 saying you're going out forever. I'm curious. Let me see how the book notated that. Let's see. Oh, there you go. They put it. They put the Z. Sure. I'd prefer. I don't really care. We're not going to do that many of these guys anyway. So if you want to put the Z on there, put the Z on there. That's it for the greatest integer function for now. I really want to just introduce the mother functions. There we go. These are your basic mother functions. Okay. You're going to need to know these. There's just no getting around it. You got to know what they look like. You got to know, okay, I've got y equals a number. That's a horizontal line. You just got to know it. I've got a linear equation. You should be familiar with that one by now. Now, you might be wondering what these ordered pairs are that I have over here highlighted. I'm actually going to print this out for you and give it to you later. Right now, I just want to look at their graphs. Just look at them. That's all we're doing today. Just looking at these graphs. So you know that a linear function does something like this. Now, why don't I have a vertical line here? Because it's mother functions, not mother relations. Vertical line is not a function. This is your absolute value function. The absolute value, we did that a lot way back in the beginning of the school year. Quadratic function, also known as the parabola, also known as the squared. Its name is the quadratic, though. Okay, real quick. You see here, we got the same points for these things, don't we? Well, for this one, it's different because it's 0, 0, 1, 1, -1. It's okay, not -1. So that's easy enough. It's the same as this guy over here, though. So a lot of these points are the same. So whenever you're graphing these, you have to know what they look like. The main difference between the absolute value and the quadratic look at the butt. The absolute value's got a sharp, pointy butt. Quadratics, nice and round bottom. Okay? If you draw a quadratic with a pointy butt, you're getting it wrong. If you draw an absolute value with a round butt, you're getting it wrong. Make sure you pay close attention to the butts on these two mother functions. All right. We also have the square root. That's what it looks like, guys. It's half of a sideways parabola. Let's see. We got the cubic. Let's see. My head's a little bit in the way. And then we have the cube root. Notice these three have the same basic points. That's the highlighted ones, the basic points for them. So you got to know what they look like. So you're going to plot those points and transform them, and then draw the image through them based on what kind of function it is. Then we got the reciprocal or the inverse or the rational mother function over here. This guy, he's going to get his own separate section. Don't worry about him right now. He's got a lot to worry about. But yeah. So this brings me to my shirt. Yes, my shirt. I had to find this shirt for you guys. I don't know if you can see it right now. Probably can't. So here's what I'm going to do. That's the shirt I'm wearing. I don't think that was me. I don't know, it might be. But yes, holy shift, look at the asymptote on that mother function. Yeah, the reciprocal mother function, he's got some stuff to deal with. But it's fun. It's just a fun shirt. I like it. My wife got it for me for my birthday a few years ago. But anyway, what you need right now, right this minute, is to start learning what these things look like. You're going to need to know what they look like. I'm not going to let you use this on the test. You're going to have to know that absolute value like this. It's got a pointy butt. You got to know quadratic. Got to know it. You also need to know those basic points. So that's what these yellow things highlighted are. They're the basic points for each of these mother functions. And if you can remember those, plot those, and transform those, draw the graph of what it looks like, you'll be good to go. The other thing is, linear, quadratic, the domain and the range. You're going to need to know what the domain and the range are for each of these. But if you know what the graph looks like, you should be able to tell me what the domain and the range are. Now, the only thing is that if we transform them, that will change our domain and our range. In 1 second.
Hey, Daddy.
Hey, Alana. Hi, everybody.
Hi, everybody.
Wave up there to the camera. Okay. All right, guys. We're about to wrap this up. Domain and range, you need to know them. Here they are. They will change a little bit whenever we transform these mother functions. Also, we've got, hang on, Alana, hang on, my love. One minute, guys. We got these guys. There you go. That's the domain, the range of those two. You're gonna need to know them. Okay. So we're gonna wrap it up there for now, and tomorrow or next week, Alana, stop. We're gonna look at transforming these mother functions. Bye. Hey, Alana, say bye, everybody. Alana, say goodbye, everybody.
Goodbye, everybody. Yeah,
Yeah, that's a Y. Very good.